Hello, this is an introduction to R and RStudio. The topics we are going to cover is a general overview of R and RStudio. We are going to talk about data management as well as plotting graphs with R, and we are also going over some basic statistics. We are going to conduct small exercises throughout this tutorial. Note that we are going to use two data sets. One is called data analysis padata.rdata, which can be downloaded from the GitHub page. And we are also going to use a small data set which is called honda.csv. And honda.csv can be downloaded in the section 2.2.1, which is called Preparation for R and RStudio. And you have the file here and here, and those two files are actually identical. So let us get started with an overview of the software. First, there is a very large user community for R if you need help or if you need online resources. If you Google any particular term, any particular topic, and you are including R in the search term, that usually leads to a very quick result, and one of the first hits will answer your questions. If you prefer to have a little bit of a more structured tutorial, there are many online tutorials available. And here I have listed two of them. One is from the University of California, and the other one is called Stat Methods. For the University of California one, it is called Statistical Methods and Data Analysis. And there is a particular web page for R where you have learning modules, you have classes, and it is basically a self-guided tutorial. The second web page, which is called Stat Methods or statmethods.net, here you can also find a lot of help with R and the various aspects associated with the software. So for example, you can click on, say, statistics, and then if you are interested in conducting t-tests, this is something that will be covered later on. You can click on t-tests, and then it shows you of how to conduct a t-test with R. Note that here on this web page, and this is also the case for other web pages that you may find, is that the input for R is in this monospaced font. Here it is Career New, and that makes you easily identify the code pieces which you would have to use. Now, there is a third web page which I have mentioned here, which is called sthda.com, and this is more advanced, and it proves particularly useful if you are interested in using R or RStudio to conduct plots with, for example, with the package ggplot2. Note that this is already rather advanced, but for example, you can have visualize, and then you have a ggplot2. So note that this is something that I am using very often. And then the software or the web page is actually very well designed, and you can see the various plots which you can do with R. Okay, so you can have, for example, density plots, or you can have histograms, and it shows you step-by-step instruction, and it gets more and more evolved, if you will, more and more complex, of how to do first starting, for example, basic histograms, or if you have more advanced design desires. So let us get back to the slides. So again, there are many online resources out there that help you with using the software and RStudio. There is not a single question that I have not been able to find an answer to online. Now, there are two additional online resources that are very helpful. However, this is not something that you can use as a tutorial, but those are web pages that are usually the result of a Google search. And those two web pages, one is called Statistical Data Analysis, and it is actually associated with the Swiss Technical University ETHZ. So you have here the web page ETHZ, and it basically is a manual for all the functions in R as well as all the packages. And what packages are, I will explain a little bit later. The second resource, or let's stay with the first one. So for example, if you click on box plot, so if you're interested in how to do a box plot in R, then I have the results already here. And note that this looks very technical. Okay, basically it tells you that box plot or the function box plot is associated with the package graphics, which is a standard package, and that it produces box and whisker plots for given groups. Now, although this seems very complicated, what is actually very useful is all the way at the bottom of the page, and that is true for any of those help files which you find, is you actually have examples. Note, those are very basic, very easy examples that allow you to recreate or that allow you to see of how the function works. Okay, and I have found those examples very helpful in the past to learn how to use R. The second web page is called Stack Overflow, and this is what basically is a resource for developers. So basically what it means, developers are software developers. Now, most of the questions that you may have, you will find your answer on Stack Overflow. So for example, suppose that you would like to know of how to do a plot where you have two y-axes. Two y-axis means you have a y-axis on the left-hand side and you have a y-axis on the right-hand side, and you would like to know of how to do that with a ggplot. Now, the reason why you may want to have two y-axes is that you want to plot two different data series that have different magnitudes. So for example, one has a very small value, very small values. The other one has very large values, and you want to plot them in the same graph. Then you may want to have two y-axes. So if you are typing into Google or ggplot or ggplot two y-axis, then you would find the result where you have ggplot with two y-axes on each side and different scales. Okay? And then it usually guides you through of how to conduct those plots. Okay? It will become clear throughout your use with R, when you get more familiar with R, of how those web pages and also how the answers to on those web pages, how it works. Now, next what we are going to do is we are going to start working in R, and I will show you the various aspects associated with the software. So when you open R for the first time, or even when you start R simply regularly, or more specifically RStudio, then you're going to see this layout. Now note that there are three parts to this layout, and I will go through those three parts, and what you will see is that the most important part is actually still missing, but I will come to that. So first, you have what is called the console window, okay, which is this very large part here. And that is where you can use R interactively. And this should only be used to do some quick calculations and should not be part of your analysis. So when I say quick calculations, for example, you want to calculate 3 plus 6, then enter 3 plus 6, you hit enter, and you will see that the answer is 9. Okay, so here what this means, this console window, is that you are entering something into R and it returns the result immediately to you. Now, on the right hand side, we have this environment, and note that the environment basically lists all the variables or the data or user created function for your analysis. Okay, so for example, if you want to know, or if you want to assign the result of 9 to a particular variable, so you can say a equals 3 plus 6, you hit enter, then what you see is that the result is not displayed, but the result is actually displayed here in the environment where it says a, or the object a, has the value of 9. Okay. Note that later on you can also add to that. So for example, you can say b is equal to 8 plus 7, or 8 plus 7. Okay, so that would be 15. And you can then say c is equal to a plus b, which would be then 24. Okay, so this is where you have the environment, and we will later see that this will store all the data, and you can think about this similar, that the data that it will store here is similar to Excel sheets. Okay, but it is much more, it is a much more flexible environment. Now the third window here, we have the which is called files, plots, packages, etc. So there are various tabs, and I will explain what they are. So you may be interested here in the help file. Okay, so basically what it is the manual associated with any function in R. Before we were talking, for example, about the function boxplot. So you can type in boxplot here, and then you can look at the help file, which is exactly the same that you have seen on the ETH Zurich webpage before. Again, where at the bottom you have those examples. Okay. Now we also have the files, and this is not really something you need to worry about. Plots is if you have any plots that you're going to generate, or any graphs, those will be stored here, and they can also be exported from this window. Now the key concept, or the key aspect of R, is that it is user contributed, in the sense that, think about it similar to Wikipedia, where people from various disciplines, from various places, are contributing so-called packages to R. What those packages do is that they are centered on a particular function. So think about, or functions. So think about, for example, that you have some statistician publishing a new paper with a new statistical method. Then the package may be representing this new statistical method, or maybe implementing this new statistical method in R. Those packages make R extremely powerful, because it is very simple to have those packages contributed to the environment, or to the software. You have to download those packages, or the packages which you would like to use, one by one, because there are thousands of them, and downloading all of them would simply basically burden your storage. So if you have identified a particular package which you're interested in, so for example, if you want to have a package which reads and writes Excel files, one of those packages is called OpenXLSX. So if you want to install this package on your computer, you click install, you type in OpenXLSX, and note that you also have this autocomplete or autosuggest, and you hit install, and then it downloads the package and installs the package for you. Note that the downloading and installing a particular package usually goes very, very quickly. So here, if you want to know of where is OpenXLSX, you can type in OpenSLXS, and then you see the package here that says read, write, and edit Excel files. You can click on this little name here, and then it gives you an overview of all the functions in the package, okay, that you can use to actually interact with Excel. Now, I mentioned before that the most important window is still missing here, and that window is the so-called script window. In order to open it, you have to click here on the little sheet with the plus sign, and you say RScript, and then you see that now you have this new window, which is the RScript file. Now, what the RScript file does is that basically think about the console like a typewriter, in a sense that you type something and you get the result immediately, whereas the script window, you are typing something and only after you are happy with what you have typed do you execute the file. Okay. So, for example, think about what we did before, where we had A, B, and C. So let's create some new values. Say, for example, we say D is equal to 17 plus 15. Then when you hit enter, nothing happens. Okay, there's no output here. And then you can create E, which is say 1 plus 2. Okay. And again, you can hit enter and nothing happens. Now, in order to execute those two lines, you can highlight them, and you can say run, and it only then executes those lines, and it stores the new values here in the environment window. Okay. All exercises which you're going to do with R, or all exercises or all analysis or statistical analysis that you're going to do with R, you are always doing it in those RScript files, okay? Because those files you can save very similar to, say, a Word document or an Excel file, okay? Whereas the output here is not saved, okay? If you have worked with, for example, Stata before, or the software Stata, then the RScript file is very similar to a do file in Stata. What we are going to create next is a script file that we are going to use throughout this tutorial, and that allows you to do, allows us to do the calculations. Okay. Now, the beginning of those script files usually look very similar, and let me just delete all of this. And so we are next starting to create a script file. So the first thing we are going to do is we are going to write a title and say, for example, R tutorial script file. Okay. And now note that everything that you are typing, what R does when you execute this script file is it reads every line and does what is written in the line. Now here, this is not something that R can interpret, so we want R to actually skip this file. And what we do for R to symbolize or to indicate to R to skip a file and not execute it is we are using the hashtag. Okay, so the hashtag basically is a command that indicates to R to skip whatever is after the hashtag. This is a very convenient to actually make notes in the document or make notes in the script file of what you are doing. Okay, Now, what we're going to do next is, and again, this is going to be very similar to the script files that you're going to create if you're working with R. We are looking at, or we are creating what is called the front matter. So basically, it's the general setup of the software. So it is always a good practice to have R clear the entire global environment first, okay, to basically start from scratch. And this is a little bit of a weird command, but you can type rm, okay, and note that usually if you start typing a command that R can interpret, then it shows you the in yellow a very basic description of the command. Okay, so here you want to remove everything that is in the global environment, and how you do that is you type in rm. Rm is for remove, and then list ls. Okay, so here when you type this, what R will do when it executes this file is that it will delete everything. So sometimes what you would like to do, if you're typing something into the R script file, you would like to see whether it works. I showed you before that you can highlight it and you can hit run. Alternatively, what you can do is you can put the cursor somewhere on the line and you can hit Control Enter. And what it does is when you hit Control Enter, it will execute the line and jump to the next line. So here you see that it has just executed the remove command and now the environment is empty. Okay. The next thing you have to do is you have to tell R where your working directory is. Now note that in the notes, in the online notes, there is a video that indicates what the file path is. If you haven't watched it, you should be, or if you don't know what the file path is, then you should be watching this video. So here what we have to do is we have to set the working directory to the location where all the files are located, or where R is going to look for files. It is always good to first check of what your current working directory is, and we are going to do this in the console down here. And you can say get wd. What it means is get working directory, okay? And then you have the round empty parentheses. You can hit enter, and here you can see that the current working directory is users Jerome. Note that R does not recognize, or the backslash has a special meaning. So here when it displays a file path, it uses forward slashes, okay? So note that this is not the correct working directory where I have stored the two data files that we need for this lecture, the data analysis pa data file, as well as the Honda. That is stored actually in a different working directory, or it's stored in a different folder. Now, to set the working directory to that folder, you have to type set wd, and then it is, in my case, it is c semicolon / users Jerome documents / R. And again, I hit Control and return, Control Enter. And note that now, since there was no error message, it now has the correct working directory. You can always verify that by saying get wd. And now you see that the new working directory is indeed the documents here. Okay. So note that sometimes you want to use packages. So for example, before we have downloaded the package OpenXLSX, and you see that it does not have a tick mark here. What this means is that the package is not yet active, and you cannot use the functions associated with this package yet. Now, it is very tempting to simply check this box here, but I strongly advise against that. What you want to do is you want to type in a library, and then you want to say that it should activate the Open XLSX. Again, here you can hit enter, and you now see that you have the little tick mark here. Note here you have a warning message. In my case, you can ignore that. There's a high chance that you are not getting the warning message. It simply means that the package was developed or was updated with a more recent version of R than I have currently installed on my computer. Okay, but there's no need to worry about that. Now, of course, very similar to any Word document or any other document or any other software that you have, it is always a good practice to save your file or save your work. So here in this case, I'm going to here save the current document. Note that here it already tells me the working directory, and I can say, for example, my first R file, my first script file. I hit enter, and now you have here the extension or the file extension R associated with that script file. Now here you have the so-called the front matter, and what you usually would do next is that you are importing your data into R. So for example, if you consider the file honda.csv, then that file is in the working directory, and we can actually load it into R, and we can use the command read.csv for that. So let me just do this very simple example. So we can say Honda. Okay, that is going to be the name of the object we are going to assign the data to, and Honda is going to appear here in the global environment. And we can say read.csv. Okay, and read.csv is a function, and here you just have to enter the name. You say honda.csv, you hit enter, and then you now have the data in the environment window here on the right hand side. Note that you have this little spreadsheet icon here, and you can click on that, and what it does is it opens the data for you. So here you have the miles of various Honda Accords that were for sale in the Indianapolis area, and you also have the corresponding price of the Honda Accord, of those Honda Accords. Okay, you can also see that you have 81 observations, which means here you have a sample of 81 cars, and you have two variables, and the two variables are miles and price. Okay, and we will be using this example later on. At some point, you may be tempted to import data manually. So note here, I have already deleted the data set again. And also note that if you want to delete the console window, you can click on here. So for example, if you have typed a equals 1 plus 2, then if you want to delete this console window, you can click here and it just deletes the console window or whatever you have typed here without deleting it here. But you may be tempted to import this Honda set manually by clicking on the from text. You can click on Honda, okay, and then you can say import, and you would see then here you would have this point and click import. Note that I strongly advise against doing so, because you will find out that it's going to be a waste of your time. Specifically, if you have set up the script file correctly, all you have to do, so once you have saved it, you can type or you can hold Control Alt and you can go R, and it executes the entire file and it automatically loads without point and click. Okay, So it may be a shortcut at the beginning, but it will you will be spending more time later on if you are importing files manually. So the next topic that we are going to talk about are what are called functions. Okay, so here I'm just going to put the hashtag again and say functions to highlight the new topic that are functions. So first, what we're going to do next is we are going to actually load this data file that is called data analysis pa.data.rdata. Note that that particular data file is not a CSV file, but it is actually a file that is specifically linked to R. So here, since it is not a CSV file, okay, you have to type in load data analysis pa.data.rdata. You can hit enter. And note that it contains not only one sheet, but it contains many sheets associated with the with this tutorial, and also actually with the entire online material. Okay. So let me get back to the slides. Okay. And so usually when you are thinking about the functions, okay, then the functions are at the core of R and they do things for you based on your input. Usually you have an object, then you have the function name, and you have various arguments. For example, what we have seen before is we wanted to load the data file Honda, then we assigned it to the object Honda. The function name was read.csv, and the argument was the actual file name. Okay, and the actual file name was honda.csv. Okay. Now, let us use some functions and see how the functions actually work. Okay. Now, for this particular example, what we're going to do is we are going to focus on the function that is called seq. Okay, and the function seq does something very simple. It just constructs sequences for you. Okay. Now, suppose that you want to know the years in which presidential elections occurred. Okay. So what you can do is you can say presidential elections, and you can use the function seq for that. Okay. And so note that the function seq, okay, so let's use the package help here. Let's do seq. And what it does is it says it generates a sequence, and it is from, to, and by, where by represents the steps. The first presidential election actually occurred in 1788. So what you can do is you can write 1788, or you can say from 1788 to 2024, comma by, and since it is every 4 years, you can say the time step to be 4. You can hit enter. So now if you want to display the results, you can either have them here, or you can say presidential. I misspelled the term. So okay, so don't worry about that. And now here you see all the years in which a presidential election was actually taking place. Okay, so if you were not sure if a presidential election took place in, say, 1892, then you see that the presidential election was indeed taking place in 1892, as an example. Okay. So let me just correct this. Just say presidential. So now note that this actually this typo serves as a very neat example. So here I made a typo. Now I have the presidential election twice here. So what I can do is I can hit Control Alt and R, or I can execute the I can mark it all and just run it. And now you see what it does. It has deleted all the files in here. It has set the working directory again to the documents.r. It's read the Honda file, and it has loaded this data file, and it has also the new presidential election is now in here. Now, note that sometimes what you can do is, let's call it presidential elections easy. Okay. So if you know the sequence of values, so here SEQ, or the function SEQ, wants the inputs to be in the order from to by. You can type in 1788, 2024, 4. You can hit enter, and it will give you the same. It will give you the same results. Okay. So here you really have to know in which order you are entering the results. Or put differently, for example, if you do not know the sequencing, okay, you just know it is somehow from, to, and by, then what you can do is, for example, you can say sequence 2 equals 2024, by equals 4, and from is 1788. So here you see that you have a different order, but you have specified the values. Then here again you are getting the same. Result. Okay. It is important to know that R also uses default values when it actually executes functions. So for example, if you're looking at the value of a t-test, okay, then you can simply enter x, but it assumes that y, and that would be a different group, would be null, or is not existent. And for example, that it adds a confidence level of 0.95. Now, this is not important right now, but later on when you continue to work with R, you should always be aware of what type of default values R is using to do the execution, okay, or to do the calculations. You can always change those default values, okay, but you have to be aware that those default values exist, and if you're not interested in using those default values, you have to make sure that you are changing those values to whatever level or whatever value you would like to have. So let's get back to the R, and let's clear the console window here, and we can leave. Let's store also the script file which we have used so far. And now note that we can also use some additional functions, or we can also use R simply as a calculator. Okay, and I'm going to give you some examples here of how to use R as a simple calculator. So let's just say a hashtag using R as a calculator. And now we're going through some examples here. Suppose that you have 10 students and you have recorded the height of those students in inches. Now let us input the height, and suppose that we are naming this as an object called height equals And then in order for values to enter, we have to use this C or sort of concatenate. And then let's assume that it is 71 inches for the first student, 77 inches for the other student, and that we have a few other values. And they are looking like this, for example. So actually, in order to make this a little bit more clear, let's delete. So if you want to delete any of the materials in your global environment, note that you can easily do this since you have written this R script, and you can always reload it by executing this line. So let's just delete this. And then let's just enter the height of those students. Okay. So now you have the height of those 10 students, and the height appears here. Now, suppose you want to know the average height of those students, then the easiest way to do that is, for example, you can say the mean height is equal to mean. So here mean is a function. Note that R tells you that you have to include x. X would be the variable or the value with values of the height, or whatever you want to take the mean of. So here we say height. Actually, let's call this average height. You hit enter, and now you see that the average height of those 10 students is 72.3 inches. Okay. There are many other functions. So here you could also say the average height of students. Theoretically, you could also just take the sum of the heights. And you know that there are 10 students, and you would get the same 72.3. But of course, the mean is much more convenient, or the function mean is much more convenient, since it automatically takes into account how many students you have. Okay. If for some reason, for example, you are interested in the squared height, note that naming objects in R, you cannot have spaces, so underscore is usually what people use. And we can say height squared. And then it turns out that R is using the element-wise, it takes each element and squares it. So the square of 71 is, or 71 squared is 5041, 77 squared is 5929, and so on. Now, if you do not want to have the heights anymore, or if you don't need that information anymore, then very similar to what we have seen above here, this RM remove. Here we have removed this, removes everything. Here we can say, for example, we can remove the average height, and note that often students always, our studio suggests what you may want to type. So here you have the average height, comma, or the average, the second one, and you have removed those elements from the global environment. A function which is also very useful is the function summary, and for that let us load the Honda data set. So here we have the Honda data set with miles and price again, and you can type in summary Honda. And then what R produces are summary statistics for both variables. Remember that we have miles and we have price. Here it tells you the minimum value or the minimum miles, the maximum value of miles. It tells you the mean, the median, as well as the first and the third quartile. Okay. So Honda is in the form of what is called a data frame. And you can think about this data frame as something very similar to what an Excel sheet is. Okay. But here you have to make sure that the variables are at the top, or the variable names are at the top, and then you have the values in the columns. Now, let us do some exercises that are involving creating and manipulating data frames. Note that here in this exercise, we are going to enter values manually into a data frame. Okay. In all the exercises that you're going to do, and most likely also if you are using R for any statistical analysis, you already have the data frame, or you already have the data which you can easily import into R and RStudio. So you will never have to really enter data manually. Okay, but let us still go through a little bit of the mechanics to familiarize with the logic here. Now again, suppose that you have the 10 students, okay, that we had before, and you have the height of those students, and let's just assign them student IDs, okay. And the student IDs, okay, here you can simply say student ID, which is the name. Again, you can use any name you like. And then when you type in 1 semicolon 10, what R does is it simply creates a sequence of integers from 1 to 10. So we have the height now of the 10 students, we have the student ID, and suppose now that we also have the student names. Okay, so let's say student names, and here again we are using the C, this concatenate, and assume that we have the name is Andrew, we have Linda, William, and Daniel, and Gina. So here you can double click on the name, and you can have the quotation marks are going to get around automatically. You have Mick, you have Sonny, and now please see the following. So here, what may happen to you when you're using R is that you're running out of space. So theoretically, you can always continue as long as you want in order to enter the names, but you can also make sure that you can insert a line break, if you will. Now here it is important that you have to indicate to R that at the end of the line there's something missing. Okay, and what I mean by this is the following. So here you have a comma, and since there's nothing after, R is expecting something after that comma. And if there's nothing on this line, it is going to look on the next line. Okay, so in this case it would be say the name Wilbur, which is the student number 8. Let's have Liz, and let's also have James. Okay, so now we hit enter. Okay, and now you have also the student names, the student IDs, and you have the height. So now you can create a data frame. Let's say the data frame is students, and you can say data.frame, and then you can simply add those 3 elements. So the student ID, the student names, and also the height. You can hit enter, and now you have this data frame. It's your first created data frame where you have the student IDs, the student names, and the height. Okay. Let us do a little exercise to practice what we have just seen. And here we are going to create a data frame where we have 5 students, and they have a score in economics and they have a score in English. Okay. So let's get back here to our script file. Again, let us save this. So here we have the 3 students, and the name of the students are the names of the students. Let's call it student names. Note that here I'm using student names with a new vector of names. So here I have Mindy, I have Weijing, I have Shubha, I have Keith and Luisa. So note here I forgot the quotation marks, so we can add them fairly easily when we mark the whole word and just type the quotation mark. So here we have our student names. Note that if I execute this line, it is going to overwrite the previous student names. Okay, and that's fine. Since we can always recreate it, we can simply execute this line again, etc. So here you also see the advantage of using the script file, that you can go back and forth. So here we have the student names. Then we are doing the economics scores of those student names. And here it is 80, 60, 95, 77.5, and 97.5. And the English scores are 52.5, 60, 77.5, 30, and 95. Okay. So now you have the names, the scores, and you can put this into the news data frame. Let's call it again students, and let's just say merge those. So we have student names, we have the economic score, and we have the English score. I forgot to economic score. Now it should work. So now you have the students, and you have the names, economic score, and the English score. Okay. So now let us do some handling with this particular data frame here. Okay. So note that if you want to return a particular value in this data frame, let's call this particular value. Okay. And suppose that you want to return the value of, say, 77.5. Okay. Then one way of doing it is to say, okay, we have the row number is 4, and the column number, it's the second column, is 2. So you can say, students 4, 2. Okay. And note that here we have say if we have some data frame, let's call it some df. Note that online you often see the abbreviation df for a data frame. We have the row number, column number, to identify a particular aspect, or to identify a particular value. So here, when we execute this, we get indeed the 77.5. Now, there are also other examples. So suppose that you want to know, well, which students had a score of over, say, 80 in the economic course. Okay, so here you are just interested in the students who got above an 80 in the economics class. So what you can use is you can use the command which is called subset, and what you want to subset is the data frame students, and you want to know where the variable economic is bigger than 80. Let's make it larger or equal to 80. So here when you hit enter, you're getting the 3 people that had a score of more than 80 in the economic. Okay, so here you see, of course, Wu-Jing and also Keith did not get a score of over 80, and they are not appearing here in the column below. So we can call this, for example, good econ students. Okay. And then you have the same also here in the as a data frame where you only have those 3 students. One functionality or one feature of R which you are going to use very often is the so-called is the dollar sign. Suppose that you want to calculate the average economics score, or let's call it, make it the average English score in your class. So before you have seen that we can use the function mean, but here we only had, when we used it before with the height, we only had a single vector. Now with mean we have multiple columns, and we have to let R know which column we are interested in. So if we want to take the mean of a particular column, then here we are just going to enter students. Okay, and in order to specify a particular column, you have to hit the name of the data frame and then the dollar sign. And here, when you hit the dollar sign, you see that R starts to display the 3 columns that are in this data frame. Okay, we have student names, economic, and English. And we said that we are interested in the English score. And so when we enter this, we see that the English score is 63. The average English score is 63. Again, this dollar sign is to specify a particular column in the data frame that you can that you are going to use for any sort of calculation. Now here you can also easily add additional columns, and suppose that you want to take the average of the economic and the English score. Okay, so how you do this, you can say students dollar sign, and then you can just specify a new name, say average score, and the average score would be students, would be the economic score plus the English score, and you can divide that by 2. And then you have the new column where you have the average score by student. So 66.25 is the average between 80 and 52.5. Okay. Note that in the lecture slides associated with this tutorial, that there's a different method where we are using the function row means. Okay, but this is just an alternative. Next, let us have a look at some basic data handling techniques with R. So let's close this. Let us save this script file, and let's for the moment clear this global environment. And what we need next is a data set which is contained in the data analysis PA data. And that data set is called vehicles. And you will find this all the way at the bottom. So let us open this for a moment. And note that here that this data set has been compacted. The original data set is much bigger. And the original data set you can actually find on their webpage called fueleconomy.gov. And it basically, you can think about the data set for all model years. You have this zipped CSV file here. And what it is, it contains all the information collected by the Department of Energy as well as the Environmental Protection Agency about vehicles that are on the market in the United States. So if you're purchasing a new car and you are having the EPA label on the side of the car, then the information based on that label is based on the information in this data file. Okay. you have many variables that I deleted to make it more accessible, this data set. But for example, you have the city fuel economy, you have the highway fuel economy, you also have information about the type of engine, the luggage volume, for example. Of course, you have the model name, you have the type of transmission, you have the type of emissions as well, etc. Okay, so it is a very rich data set. It's also a very large data set. And basically here you have 42,702 observations, and it's basically all the model years from, in this case, from 1984 to 2020. Okay, so for each model year, what type of car were available for purchase. Okay, and so this is the data set that we are going to look at right now. Okay, so let's go. Let's create some space down here. Okay, and the first thing we are going to do is we are going to subset this data set again, and we are only going to look at cars of the model year 2015. So to do this, this is very similar to what we have done before with the English score, yeah? or the economics score. We say cars 2015 is equal to subset. Then you have to say what you want to subset. Here you want to subset vehicles, and you want to subset where the year is equal to 2015. Now here it becomes important. Suppose that you're only entering one equal sign, okay? Then R is not going to recognize this single equal sign, okay? And when you execute this, you do not get an error message, but you end up with the same data frame as before. Now, what you want to do is you want to conduct a logical test, okay? And this is also similar in other software packages. And you have to enter a double equal sign to conduct a logical test. A logical test, what does it mean? R is going to take the data file vehicles. It is going to look at the column year. So the column year is here. And it looks of where is that column equal to 2015. Okay, and then it's just returning those values. So when we now execute this with a double equal sign, now we see that we only have 1,283 cars. And what they have in common is that they're all of the model year 2015. Okay, so there's just one value of 2015 there. Okay, so that is the data frame we want for the following exercises. Okay. Now, suppose that when you look at the cars 2015, you see that the EPA is categorizing those cars into various classes. Okay, so here you have 1,280. You have 1,283 observations, and you have some subcompact cars, compact cars, small sport utility vehicles, two-wheel drive, etc. Now, suppose that you are interested in, well, how many unique values are actually in that column. Okay, then you can do this by using the function unique. You can say cars 2015 $, the vehicle class. You can hit enter, and then R is going to list you all the various categories, vehicle categories that are in that column. Okay, so here you see that you have, this is 22 different types of vehicles in this column. Okay, you can do, of course, you can do the same if you are, say, you are interested in the make. Okay, then you can have here that there are 45 different makes in that data frame. Okay. Now, suppose that, let's continue here. Okay. Now, suppose that you want to calculate actually or you want to get information about the average GHG score, or the average greenhouse gas emissions score by vehicle class. Okay, and for this you would only need the two columns vehicle, the two columns vehicle, V class and GHG score. And then when you want to in this exercise, so you're not only subsetting for 2015, but you only want to have two columns returned. And then to return specific columns, you can enter them. So here it would be GHG score and V class. So here when you hit enter, now you have only two columns with the GHG score and the V class. Okay. Now, here in this case, when we had the original column or the original data frame vehicles, we were just looking for one value, or we were just testing for one value, this logical test, when we said we want just the model year 2015. Now suppose that you are also interested in the specific vehicle class, but you're not interested in one vehicle class, but you're interested in two vehicle classes. Okay, so here the subsetting gets a little bit funky looking, if you will. So here, what you're doing now is, suppose that you're interested in, let's note this down, your interest is in, suppose it is in large cars and small cars or compact cars. Okay. Then here, so you want not only the year 2015, but you also only want those two classes. So what you can do is you have to enter the and sign. So here you want the year and particular classes. And so here we have to type in the V class. And now here the notation becomes a little bit weird. You have to use percentage in percentage. And you have to specify the values that you are interested in. So in this case, it would be large cars and compact cars. So here when you hit enter, you have the cars 2015. And note that you now only have 321 observations. And you have the only compact cars, and you have only the GHG scores associated with those cars. Okay. Now what you can do is you can use a function called table, and you can say cars 2015 $sign V class, comma, cars 2015 $sign GHG score. And then what you see here is this, or what you're getting is this table where you have the compact cars, the large cars, and then you have the GHG score here. Okay, and so the higher the GHG score, the more environmental friendly the car is. And you can see here that you have, for large cars that are of course heavier and you're using more fuel, that you have the scores, the majority of scores in the 4 and 5 range. Whereas for compact cars, you have the scores in the, or the majority of scores in the 5 through 7 range, even 5 through 8 range. Okay. So the subset is something that I'm using, or the command subset is something I'm using very, very often, or the function subset. And it is very useful if you really want to boil down your data and if you're only interested in certain aspects of the data. I have to admit that it does require a little bit of care of how you enter. So for example, that you have the double equal sign, or that you have this, percentage in percentage if you are having multiple values. but it is an extremely useful function. Next, let us do an exercise where we are extracting the GHG score by vehicle class. This is very similar to what we have done before, but we are also interested in 4 manufacturers, actually 3 manufacturers, Toyota, Ford, and Audi. And we are going to do this extraction for the model year of 2014. So let's get this started. So let us actually copy this before. Let's just call it Cars 2015. We are interested in the model year 2015, and we are not interested in the vehicle class, but here we are interested in the make of the vehicle. Okay. So here the makes that we are interested in is Toyota, Ford, and Audi. So we have, note that we have Toyota, we have Ford, and we also have Audi. So Ford, Toyota, Audi. And here we are now also interested in the make. Okay, or we want to select the column make. So we hit enter. And then when we are looking at Cars 2014, now what we have is we have 193 cars that are associated with the 3 makes, or 193 models associated with the 3 makes. We have the vehicle class, and we also have the GHG score of those vehicles. Now, when you look at the data frame, okay, then you'll see that, let's take, for example, let's take Ford, for example. Okay. And it turns out that if you are interested in a quick look, in a quick filtering of the data frame, you can hit filter, and suppose that you're interested just in Ford for the moment. So now you only have the Ford entries displaying. You see that you have Ford and you have multiple compact cars, and they all have different GHG scores. Okay, so Ford has here in this case, say, I don't know, a bunch of compact cars. They all have different GHG scores. Now suppose that you're interested in calculating what is the average GHG score for compact cars made by Ford. Okay. Or what is the average GHG score of large cars made by Ford. Okay? So we are going to use a function to calculate this, and this function is called aggregate. And what the function aggregate does is, depending on how you specify it, it will take Ford, it will take the subcompact cars of Ford, and it will calculate the average score by group. Okay, where the group is composed of the vehicle class and the make. So let's call it average GHG 2014. And the function that we are going to use is called aggregate. Okay. And so here again, you have to be very careful of how you include the arguments in this function. What you want to take the average of is the column GHG score. Okay, so let's start with that. So here you have Cars 2014, and you want to take the average GHG score of, you want to take the average of the GHG score. So then you have to specify the function. Okay, so here you want to have the mean of the GHG scores, and then you have to specify the categories or the groups. Okay, and here you have to say by, and then you have to enter what is called a list, and it would be the Cars 2014, the V class, comma, and actually let's just have a look. If you just execute this function, then you have the average GHG score here. And note that you now have in this group 1, you have the various You have 20 vehicle categories. Those are all unique. And you have the average GHG score. But note, it is not differentiated by make. So in order to get the make, you also have to say cars 2014 $make. You hit enter. And now you see now that you also have the compact cars by make and the average GHG score. So before we were, for example, interested in Ford, or actually let's sort this column by compact cars. And you see that Toyota, or the compact cars made by Toyota, have the best GHG score, whereas the compact cars made by Audi have the lowest GHG score. So this function is actually this function aggregate is very useful. The only problem is that unfortunately it does drop the column names, but what you can do is you can say average, or you can use the name you can use the function col names, average GHG score 2014, and you can say you want to call this V class, make, and GHG score. Say V class, make, GHG score, and then you see that you now have those correct column names. Now note that we have also, then we have this data frame now, and suppose you want to export this data frame, so you will have to type the following. You can say write.csv. Then what you want to write, the data frame average GHG score. And then you have to specify the name. Say average ghg.csv. You hit enter. And then when you open your working directory, you now see that you have the function, or you have the file average GHG score in the in an Excel file. Okay. So again, the function aggregate as well as the function subset is something that is used very often, and that is also very powerful to quickly generate summary statistics or to quickly subset your data. Next, let us extend the basic table function which we have used previously. Now, for this exercise, we are going to use the data which is called GSS, specifically the GSS gun. The GSS data is, or the GSS stands for the General Social Survey, and it is conducted every year in the United States to keep track of social trends over the past decades. For this particular example, we have the age of the respondent. So we have 1,300 respondents here. We have the age, whether they own any firearm, and also their sex. Now, if we type in, if we are interested in a difference between owning a firearm and the gender, then we could use simply say table GSS gun $own gun, comma GSS gun $sex. And then what we would have here, we would have a very simple table that says that out of those 1,300 respondents, we have 232 that are owning a firearm and that are male, and we have 208 that are owning a firearm and are female. Okay, so here it is actually very difficult to interpret what the percentages are associated with the gun ownership and the gender. So what we are going to do next is we are going to use a new library that is called gmodels. So if you have not yet installed this library, or this package, you can just go on package, you can type in Gmodels, and you can install it. So in my case, I have already installed it. So let's activate it. And now let us do the same as before, but we are using a function that is specific with Gmodels, and that function is called Cross-table. Now here we are going to have a lot of output, and let us have a quick look at the details here of this output. So first, note that we have Gmodels. It gives you a little explanation of what's going on here. So you have, for each cell, you have 5 values. Okay, so here we have, for example, we have yes and male. So here we have the total number of people, of observations that are in that category. Okay, now ignore the chi-squared contribution here, but we have n over the row total, the number of observations of the column total, and so on. So what does this mean? So let us have a look at the third value, which is this value here. Okay, so or those two values here. So what this means is the following. It means that of those people who own a firearm, 52.7% are male and 47.3% are female. Okay, and here the row total means that 33.8% of all respondents in the dataset own a firearm. Okay, now this would be the third value, which is the total number over the row total, but you also have over the column total, which would be the fourth value. So let's consider this value here and this value here. So what this means is that from all the males in the dataset, 40.1% own a firearm and 57.9% do not own a firearm. For female, we have of the females in the dataset, we have 28.8% own a firearm, for which it is yes, and 69.5% do not own a firearm. Okay, so this function cross-table is gives you much more detail about the various proportions in your data. And of course, you can always say, for example, let's call it some output. You can always store those values, right? And you now have the various tables. You have the various tables. You can access the various values in the table from here. Okay. I mentioned before that there are two functions that are very useful, which is the aggregate and the subset. And there is also a third function that is used very often, and that is the function merge, okay, in order to merge various data sets. And we are going to use this function now to merge data on Ohio schools. Specifically, we have two data frames. We have two data sets. One is called Ohio Score, which contains an identifier column called IRN, and you can think about this as the identifier for the various school districts in Ohio. Okay, and then you also have the score associated with the school district, which basically is, think about it as a measure of the quality of the school district. Then in a second data set we have which is called Ohio Income, we have again a column that is called IRN, which identifies the school district, but we also have the median household income and the enrollment in the school district. Okay, So when you look at the data, you have the two data sets here. Let me just get rid of all this. You have the two data sets here, and you can see you have Ohio income, where you have this identifier, you have the enrollment in the school district, and you have the median income. But then you also have the identifier and you have the score, okay, which basically is the quality of the school district. And what we are going to do next is we are going to merge the two data sets, that we have a data set which has the identifier, the score, enrollment, and median income. Let's call this simply Ohio school. And then we can say merge. And then we have to specify what we want to merge. Here we want to merge Ohio score and Ohio income. And we want to merge this by IRN. Okay. So you enter this, and now you see that you have this data, Ohio school, where you have the IRN, the score, enrollment, and the median income. Now note that by default, the function merge only takes matching data. So here in this case, you see that we have the income contains 607 school districts, the score includes 608 school districts. It means that for one school district, there is no income data. If you would like to know which school district that is, what you can do is you can say all, and say here, say all X or all Y. So here we know that for Ohio score has more school districts. So we can say Ohio score is here as the X. And say Ohio is true. We can hit enter. Now we say we have the Ohio schools, which now has 608 observations. And we can see that for one of those school districts, let's see which one it is. Then now you have all the school districts, and there is somewhere a missing school district. And here we go. We see that for the school district 48975, there is we just have the score, but we do not have information about enrollment and median income. Okay, but let's delete this and let's just look at the school districts for which we have complete information. Okay. We are not going to work with this school data right now. We are going to continue to look at some plots before, but we are going to get back to this Ohio school district data at the end of this tutorial. So what we are going to do next is we are going to look at some of the plotting or the graphing abilities associated with R, okay, or RStudio. Now, the data set that we are going to work with is called Faithful, and Faithful is actually a data set that comes with R. Okay, so you can hit Faithful. And now you see that you now have this Faithful data set, and what it is, it indicates the eruption time and the waiting time, so the eruption time in seconds, the waiting time in minutes of this Old Faithful geysir. Okay. So in the first step, let us just have a look at the summary data. So if you are ever going to the national park and you're looking at the geysir, you can see that on average you're waiting about 71 minutes. And that the average eruption is about 3.5 seconds. Okay. Now let us plot the eruption time on the horizontal axis and the waiting time on the vertical axis. Now to do so, you can simply type plot Faithful eruptions. So that is on the horizontal or the x-axis, and then faithful weighting on the y-axis or the vertical axis. And you get your first plot here. Note that you can click on zoom, and then you can the window gets a little bit bigger. And so now here what you see is something very interesting, in the sense that you have a positive relationship between the eruption and the waiting time, okay? But you also see that there's a clustering here and here, in the sense that either you're waiting a little bit or you're waiting just say 50 to 60 minutes, and you're going to see a short eruption of about 2 seconds. Or if you're waiting a little bit longer, between say 80 and 90 minutes, then you're getting eruptions lasting between say 4 and 5 seconds. But note that you have a very little going on between 2.5 seconds and 3.5 seconds, okay? That there's a gap here in terms of eruption time, and the same is true for the waiting time, okay? So sometimes, or very often, it is actually useful to visualize your data to see patterns that you may not necessarily get with numerical summaries, okay? So here, when I say numerical summaries, you can think about the median or the mean. Okay, it does not give you any indication that you actually have this clustering into 2 groups of short waiting time, short eruptions, and long waiting time, long eruptions, but that you don't have anything in the middle. Okay. So again, note that here you have your first graph. You can also export this graph either as an image or as a PDF, or you can also copy it to the clipboard such that you can later on insert it into a Word document. So let's do this quickly as an example. You can just say copy to clipboard. Okay. Let's just say copy plot. And then when you are doing this in a Word document, you now see that you have the figure included in the Word document. Now, what I find very useful with R is that you can actually plot pictures of graphs side by side, okay? So suppose that you're doing a histogram of those eruption data. So what you can do is, for example, you can say histogram, or the function histogram, and you can say faithful and the eruptions. Okay. Then you have here now your first histogram about the eruptions. So in terms of where you have on the x-axis, you have the seconds, and you have the frequency on the y-axis. Now note that you have a weird title, and a weird x-axis description, and also you don't have the full scale here. So you can change that. For example, you can say the main or the function main is the title. Let's call this eruption time. And you also want the label of the x-axis. So you want this in seconds. And then you can also say the limit of the x-axis is, say, between 1 minute and 6 minutes. So you can hit enter, and now you see that you have a slightly better picture. To be honest, I think this is in seconds. It may be in minutes. I've never been there, but let's assume it is seconds. And you can also make sure that the axis on the y, or the y limits, goes from, say, 0 to 80. Right. So now you have this. This plot here, and you can then use this later in the wherever you need it. Now, suppose that you're not only interested in the plot of eruptions, but that you're also interested in the plot of waiting time, then you can say waiting here. And note that the waiting time, let's call this waiting time is definitely in minutes. And the minutes go, say, from 40 to 100 minutes. And that also, again, here we can leave the limits to from 0 to 80. Now here you now have the histogram of the waiting time. Now, if you want to plot both of them together, you have to use this function called par, which is basically looking at the dimensions of the plot, and you have to use mf row equals 1, 2. Okay, 1, 2 indicates the dimensions, so it's 1 row but 2 columns. And then when you execute both of this at the same time, you now see that you have a graph where you have both images or both plots, waiting and the eruption time in the same plot. Okay, so this is something very useful. So let us get back to the Ohio school data. Actually, before I forget, note that you have the various plots. You can scroll through the various plots here, okay? And you can also delete the plots that you don't need. So this function here clears all plots. This one just removes the current plot. So for example, we have seen that this one is not very pretty, so we can move this plot. This plot doesn't work very well, so we can remove it. And so now you only have the plots that you are actually wanting. Okay. So let us get back to the Ohio school and let us do a slightly more complicated plot. And note that this is well beyond the initial tutorial here. Okay, but I think it represents very nicely, or it presents very nicely, the power of R, and also how you can actually put a lot of information into a single graph. Now, in order to cut down on the typing, what I'm going to do is I'm going to copy what we have here. I'm going to copy this directly into the R script. Okay, then I can concentrate more on explaining what is going on here than on the typing aspect. Okay. So first, what we are going to do, note that we already have Ohio school. This is the data set which we have created before, and it is here. Now, the two functions that we are going to need for plotting this, or the two packages, are ggpubber and ggsci. So if you do not have those functions, and you probably don't have those packages installed, so please do so. And then you can activate both packages. So what we are going to do here is we are interested in the Ohio school data set and whether the scores or the quality of the school depends on the income of the school district, or the median income of the school district. And we are going to categorize those, the median income, into 4 categories. We are going to, basically the 4 quartiles of median income. So we are going to have the lower income, or the 25% school districts with the lowest income. We call those lower. Then we have the lower to lower middle income. We have the upper middle income. Okay, and then we have the upper income. So the upper would be the 25% of school districts with the highest income. The upper middle category would be the school districts between 50 and 75% of income. So what we have to do is we have to use this function quantile. Okay, that is basically categorizing those school districts. Let's just call it top and bottom. Okay. And then what it does is, let's plot this, or let's just display this. Okay. So here you have those incomes. So first of all, note that the lowest income is $14,602, and the school district with the highest median income is $73,122. So here you see the 100%, the 0%, you see the lowest median income and the highest median income. And then here, those are the cutoff values, okay? Which means that in order for a school district to be in the top 25% in terms of median income, the median income value has to be between $37,000 and the $73,122. Okay? So next, what we are going to do is we are going to calculate those quartiles. Okay, and here let's add the quartiles here directly to the school district. Okay, in the next file, in the next step. And so what it does is the following. So now you have the quartile here. Okay, you have this new column quartile, and it says the 1, 2, 3, and 4. It says whether a particular school district is in which quartile it is. So if is it in the first, or if it's in the highest quartile, which is the 4, or in the lowest quartile, or in the lower middle or upper middle. So for example, consider this value of 30,000, or this school district with a median income of 30,975. Okay, then you see that this school district is not in the lowest income category, but it is actually in the second to lowest, so in the lower middle class. Okay, that's where you have the 2. If you consider this other school district, for example here, the 54,000 is clearly above the 37,000, and this is then in the highest income category. Okay. Now what we're going to do next is, here we have the numbers, and we are going to assign names associated with those numbers. Okay, and so we are first creating this new column here, where we just say, let's call it a generic income that has no value at all right now, no values in it right now. And then what we are going to do next is we are going to say we are going to assign in this column Ohio income. We are going to assign the value of lower if the value in quartiles is equal to 1. Okay, so let's just execute this first, and then you see now that everywhere where we have a quartile, where the quartile is equal to 1, the income, the name we associate with that group is called lower. Okay, and then if it moves to 2, we do not have any values in it yet, but this is going to happen with the next 3 lines, which then now completes the income. So for example, everywhere you have the top school districts in terms of median income, you have it as upper, okay, or upper income category. And so next, we are going to plot a density function of the school district in terms of score and how the scores vary with income. So let's just, I'm just going to execute this line here, and then we are going to have a look of what exactly is displayed. And note that if you were to do this with Excel, you would have a very hard time because there's a lot of information in this graph right now. So let's have a look at this. So at the bottom, you have the score, which measures the quality of the school district. Okay. And then you have the distribution associated with the income classes. Okay, so here So the gray one is the upper income, okay? And then you have the blue one is the middle income. And unfortunately, not surprising, you see that if you have the upper income or the school districts with the top 25% of in terms of income, that they have on average a much higher score, okay, than the bottom income, okay? And that there are, for the upper income school districts, there are very few that are having a score below, say 80, okay? And you can see that for the lower income class, okay, at least here in Ohio, that for the lower income, or for the bottom 25% school districts in terms of income, that the average score or the mean score is even below 80. Okay, and so you have this very large concentration of low scores associated with lower income school districts. You can see that in the middle class here, or for the lower middle class and upper middle, so the yellow and the red, that those school districts are actually very similar in terms of performance, that you have are very similar in terms of performance, but there's a big difference of the lower income and the upper income class. So here you can see that you can get a lot of information out of a graph, okay? And that is also very easy to plot this type of graph with R, relatively easy, okay? Now this, of course, this type of thing goes well beyond this tutorial, okay? But you can think about that this type of graph would be very neat to have, say, in a report, and that you would just do this type of commands only once to actually generate this type of graph. Okay, and so now this also finishes the tutorial. Thank you very much.